coming over today. I'm super happy to talk to people in person after all these years. And my name is Alberto Ríos, and I'm a software engineer in VMware. And I'm here today with my friend and colleague Abel Salgado, also from VMware. So Abel and I have been working together over the past few years on making developer tools for Kubernetes. So we are part of the Spring Cloud team in VMware. And we had to learn Kubernetes from scratch. That was something we didn't know. It was not really our expertise. So we had to go and learn from zero what that meant, what meant to develop forkates and ship products in Kubernetes and all that. So this is kind of why we're here, just to share our personal experience. So just to get an idea, who has ever used Kubernetes before? Cool. Who's using it in production? No, okay, one, thank you. Cool, no, that's really good, So moving applications to production in Kubernetes can seem kind of easy at first, because there are some basic concepts that look very easy when you start working with it. You know, you get the idea of having a deployment, like a replica set, you know, it's gonna create a new pod, it's gonna do all that magic for you. You know, it has all this config set, you know, all these things are very easy to understand at first, but then when you go deeper and deeper and deeper, it gets really nasty. So there are many tricks and things that are not trivial the first time you start working with it. And this is kind of what we wanna share, some things that we consider basic, that we didn't know when we started working with Kubernetes. So this is kind of just sharing what we have been learning over these past few years. So this is what we are going to be saying. Again, this is going to be very opinionated to our personal experience for the use case that we had. So the first one is going to be choosing the development cluster, which I'm going to talk now. Then some nice tools, some good security practices, and then how to deploy things. And some recommendation about bibliography and blog posts that we follow. So the first thing, when you start working with Kates, especially in our use case, because we had to talk to the Kubernetes API for creating these services, we had to choose what development cluster to use. Like, how do we test things locally and also in our continuous integration pipeline? Right? That was something that was not obvious for us. Like, there are many tools available for you. We studied a few, and we are going to say at least the pros and cons of some of them, and the reason why we chose the one we have chosen and what we have been done today. So the first one we're going to talk about is Microkate, which is by Canonical, aka the Ubuntu folks. And this one is really cool because you can manually control how to configure every single node cluster, which is really powerful. So you have control of everything that you want in your node images. Also, it has a really nice to use add-on system that you can install anything that you want an ingress, you can just install it with one command and things like that. The problem is that it takes a long while to provision a cluster if you're using Microkates. So that's something that we couldn't really afford all that time. We couldn't really do it for our continuous integration.
1, 2.
Oh.
Okay.
Definitely the different, this is from a different room. Okay. Help.
Yeah. Check 1, 1. 2. Check 1, 1, 2. 2.
I don't know what's going on.
It's not me.
I'm not the audio guy.
No, you know, okay.
1, 2, 1, 2. 1, 2, 1, 1, 2. 1, 2.
Hello?
Maybe restart the system.
I wish I was the audio guy. I don't know any of these systems.
That's okay. Shall we continue or?
Yeah, continue. I'm gonna track down the guy who knows how to.
Okay, thank you. Okay. All right, you would think that outside of Zoom this wouldn't happen, but hey. So we were talking about Microkate, and we said it was nice because you have all the control of all your node clusters, and you have a really nice add-on system where you can install things very easily. The problem, that for our use case, it wasn't super easy to use because it takes a long while while running that command. Right? Then we took a look at Minikube, and it feels very real because it's the closest thing that you can get as a testing cluster closer to the vanilla OSS Kubernetes distribution. So that felt really good. However, it was not light at all. So it was not something we could install in our CI system. So we decided not to use that either for our use case. Then Kind, that stands for Kubernetes in Docker, is the tool that we started using as soon as we saw it, because you can get a development cluster in just seconds. And even though it's not a real distribution, meaning that every time you are going to create a cluster locally, so for example, you need a configuration for like an ingress, and then for kind, and then for GCP, you're going to have to find the ways in order to configure these two things. And that's kind of sad, right? Because you have to tune, you want to use some specific features. This is very distracting.
So they're supposed. Yeah. So this is the 11 one, but.
Yeah. So, can you go?
I don't know.
¿Por qué no te acercas, tío? Y lo dices.
Pero ya es el otro, ¿no?
Ya, pero no sé.
¿Se supone que es la del otro lado?
Sorry about that. I guess I can continue-ish, or just wait a bit. I think. Are you okay if we wait for a bit just to solve this? It's kind of distracting. Thank you. Oh well.
Whoops, sorry.
Yeah, definitely not an easy. Oh well.
Have we located the person or?
Yeah, I'm looking for him. I can't find him.
How's it going?
Okay, but the sound comes from this room?
I'm not sure which.
Yeah, I'm not sure. This one, I guess. It's because I'm assuming it's the closest to one. For instance, I'm trying to hijack the session. I think I can see that. Do you hear that?
Yeah. I don't even know what to do.
I guess for now, just we're just not going to have audio for.
Definitely not.
Okay, or maybe we just.
Turn off your mics.
Yes.
Are you submitting to these audience?
Yes, and even from another room, because there was a girl talking, and I don't see a girl there. Maybe the girl is from above?
So we're gonna start again, but let's wait for this to be fixed.
It's not a room.
I've got a guy coming.
Okay.
Thank you.
Okay. Va peor. It's going worse.
Yeah, sorry.
That's okay.
Apagar el micro e intenta hablar de voz.
But the problem is I cannot disconnect this thing. Right.
Yeah, but you can just turn off.
But this is gonna turn off our mic, not the whole system. No?
Oh, fuck.
I've got someone coming.
Cool. But
Yeah,
I
but
guess
can we
it's
at least
someone-
disable the speaker?
Oh well.
No, que no hay que preocuparse.
I don't know it.
That's okay.
I've never seen this.
It's fine, man. Well, can't you just turn off the thing
Yeah,
that
that is
can yell,
a
I guess?
switch here. I mean,
I guess just.
I'm just a software engineer, but...
I can yell, I guess. Hello.
Okay, that's the timer for the explosion. Do you speak? No.
So at least we're not going to get other people coming into the rooms. I guess just we're going to go manual
¿Puedes hablar?
for the
I
moment.
think so.
Pues pídeles que vengan para adelante.
Someone
Can you hear me okay? I'm sorry, there's a problem with the audio system, so I don't think we can use the speakers. Do you mind getting closer so we don't shout a lot? I'm sorry about this. We have no idea what is going on, really.
Yeah.
And we can't really give the talk while other people are talking over. Sorry about that. Thank you. Thank you.
Hey,
Hi, man.
got your mic?
Yes.
I heard that y'all needed some help, so I was popping in.
Yeah, but
Yeah,
yes, sound
we
from
don't
other
really
rooms
know.
are coming through speakers. We just
Yeah.
turn off the speaker.
Yeah, we're turning
We're
off
going to
because
do
of that.
the talk without the microphone.
Yeah.
Yeah.
You turn it on, you will hear
Yeah, we
people
just
doing the mic test.
Switch,
across.
switch this here.
I got you.
Okay.
So maybe it's
Let's work it out. Oh, you turn it back on?
no.
No. Up to you. Like, I don't.
I mean, we were just going to.
Is it okay? We just shout for a while.
Yeah, it's fine.
Do you
Do
want?
you think
Okay.
Okay, thank you.
Thank you, man. All right. A cappella.
¿Empiezas?
Yeah. Yeah, no, está fácil. Okay, so let's start from zero, I guess. So thank you very much for coming over. My name is Alberto Ríos. I work from VMware, and I'm based in Seville, Spain. And I'm here with my colleague Abel Salgado, also from VMware, and he's based in Barcelona in Spain. And Abel and I have been working together over the past few years on building developer tools for Kubernetes. We are part of the Spring engineering team. We typically work with Spring Cloud these days, and we have to learn how to ship products for Kate these days. And it's been a few years, like I knew nothing. No? Yeah, like there's no mic.
Yeah,
because
yeah, please just.
If you can come closer, please. Like, I don't know if I can shout for like an hour.
Yeah.
Yeah. So we had to learn how to use Case from scratch. I knew nothing. Like 3-4 years ago, when we started prototyping these products that we were gonna ship. So it was something that we had to learn from scratch, right? So the goal of this presentation is to share all that we knew. We kind of wish we knew when we started working with Kate. So who here have ever used Kubernetes before? Yes, used it? Cool. Okay, a lot of folks. Like, who's using it in production today? Oh, wow. Cool. Good stuff. Okay. So when you hear about Kate at first, it seems very easy, right? Like all this basic concept, like you know what Docker is, like this replica set is cool because it does a lot of things automatically for you. But the more you work with it, the deeper you get into understanding what's happening. It's kind of shadowy, like it's not really easy to understand, especially you go to all these mutating webhooks, all that. It's not that trivial when you are working in production. So we wanted to share a lot of the patterns that we have learned across the way and some of the tools that we found useful for our use case. So again, this is going to be very opinionated, right? So this is something, we're going to start talking about some tools for working locally, what do we use for iterating, some security practices that we found crucial and I have no idea about, and then some demos. And some books that we're going to recommend and articles. Okay, so the first thing we were asking ourselves is how do we test stuff, right? Especially because our use case, we had to test and talk to the Kubernetes API. And that meant that we couldn't just build a microservice and ship it, right? So we have to worry about these things. Thank you, sir. Let's see. Hello, 1, 2, 3. Good. All right, thank you, man. Let's see if I can do this now. Okay, good. Woo, thank you. All right. So I was saying that for us it was very important how to test things, right? Because when you have just a microservice because you put in Kate, you don't care about the Kubernetes API, so you don't even care where you're shipping that to. Like Kate can be one of the platforms you develop that against. In our use case, because we are building services that talk to that API, we couldn't afford not testing all these integrations, right? So we need a cluster that was fast to use, so we could add that into our continuous integration pipeline. But we also wanted it to be kind of closer to reality. Like we didn't want it to just mock the whole thing, all these integrations. We wanted something kind of real, so it was kind of a weird situation for us. And for that, we studied all this, there are way more development clusters, but these are the ones we kind of choose to take a look at. And we are going to talk about the pros and cons of each of them, and why we chose what we chose, and maybe, it's been a couple of years now working with this, what would have been chosen today. So the first one is Microkate. This is by Canonical, aka the Ubuntu folks. And the good thing about this is that you have all the control of your images, all the node images, meaning that you can exactly choose what you want. You have that specific requirement, which is really nice for creating worker nodes. And it also has a really nice add-on systems, meaning that with one command, you can install whatever you want. You want a local persistence, you have it. An ingress, you have it. So just one command and you have everything. However, it is very slow when you want to install, you want to provision a cluster. It takes several minutes. It has some system requirements. So it wasn't that good for our continuous integration. So we decided not to use that. Minikube, it was really good because it's probably the closest to a vanilla OSS Kubernetes distribution that you can have for testing. However, it was not light, like something we couldn't afford to add into our pipelines at all. It was very good for local things, but not for continuous integration. So it is something that we couldn't use either. Then we found Kind, and you get a cluster in seconds, like my machine was like 30-ish. And this is really nice because even though it's not a real distribution, you need to tune things. Like, for example, we have an ingress that we install for our testing in Kind, and we have another ingress that we have on GCP when we deploy to a different environment. The problem is that these two files are very different, so you have to maintain two sets of files. depending on what you do. We decided to go with it because really 30 seconds to have a fresh new cluster that you can use. And in the end, we don't install that many components really. So just learning how to do an ingress twice wasn't that bad. So we decided to pay the price. And how do we use it? It's something that is interesting, I guess. We tried to create a test container module for this, but we couldn't. Why? Because all the business logic does not happen into the kind image, it happens in the CLI, meaning that we will have to go and translate all the CLI Go code into Java. And every time there's a new version, we'll have to redo the whole thing over and over and over. So it's a price we decided not to pay, like we couldn't really afford having to maintain all this tooling just for testing. So we did the not elegant at all solution, but very functional, which is just calling kind create on every single setup. Until then, we kind delete cluster. For every single test, we have this context, and this is what we use for testing. It's not elegant, it's not cool, but hey, it works. It's been working for a couple of years, and it's stable. So this is really what we wanted, right? Then we found about K3S, and honestly, it's been really nice. It's a real certified distribution. Started with Rancher, then it was bought by SUSE, I guess. And it's really lightweight. So one of the things they did was they swapped out ATCD and replaced it by SQLite 3. And that means, you can do whatever you want, but by default, they have some really nice defaults and everything just works. So you see, you can read very well, but you have MetaLLB, you have other really nice things out of the box that you can install, and it's a real distribution. So that was really nice. And also you see it's as fast as kind when provisioning a cluster. So it's something that we would have known about this a few years ago. We might be using this, but particularly now, today, the test container folks have a module where you can use K3S out of the box. So this is really nice. Like you think about the first line is what we do with this command that we had, right? This kind create, but they created a module just for the K3S where you can start testing against this distribution. So if we have known about this or this existed a few years ago, we probably will be using this even today. But because what we have works, we decided not to move around. So if I was starting today, maybe this is what I will be using. But what we have works, so why changing, right? So as a small summary, we have Microkate. It's good if you need control of all your node images. Then you have Minikube that is good for, because it's the closest to a vanilla open source distribution. Kind is just fast and really reliable. And K3S with K3D just gives you a very nice experience. If you don't care about how opinionated they are with what they provide, it's really good. Okay, any questions so far?
What does K3D provide?
It is a wrapper on top of K3S. So K3S is the actual distribution, and K3D is a CLI that gives you the same kind create experience. So just a CLI, a light wrapper on top of the whole thing. Thanks. And with this,
yep. Your integration environment or your development, like on your laptop?
Both actually. Abel is going to go farther because he's going to show the tools on how we actually work, but we use for both. So we have kind nodes running in our continuous integration environments, and locally we have, like when you're our guys, you will see how we do it now. We do kind create cluster as well. So it's kind of nice because you can do the same both locally and on CI, and that was crucial for us.
Yeah, the message that he showed before in the slide, like all these lines in the kind slide, is that you just run kind create and it takes like half a minute in a normal computer and you get a cluster running. Everything is local.
Yeah, like so so we parallelize a lot of our tests. So we have some tests that we call component tests, which is like black box tests for some of our components. And we parallelize them because if you have enough RAM, like you can run even 5 kind create cluster parallelly, even locally in your machine. So it's actually, if you have a good CI environment, obviously, but you have some RAM spare, you can even do that locally with some parallelization. So it's kind of nice. That's why, again, we found this is not close to anything real, but it's fast and that works. So. Alrighty, time to actually see things.
Yeah, demo time. Can you hear me fine? Yeah, okay. This is the URL for the repo I'm going to use if you want to clone it, and the QR. If you want to use your phone just to grab the URL. And I'm going to show you a little bit like, okay, now that we have our cluster selected, in this case we choose kind, let's see how we can get a nice developer experience to do some exercise. I'm going to focus on the tools, not on the exercise itself, so don't worry. And we're going to see basically this set of tools. Scaffold, first of all, Cloud Code, K9S, Octan, and at the end, Kube Context and Kube NS. The last ones are quite simple and silly, but it would be a shame not to show them because it's maybe a thing that we use more often. Okay, so if you clone the repo, you will see it's a simple Spring Boot application with a normal REST controller with a hello world that just returns some HTML and a message, nothing special. The important thing is what I was mentioning about the scaffold. The scaffold is just a CLI tool that helps you handle the deployment and lifecycle of your application. From the beginning, at total beginning, like, okay, how do I build and compile my application from source, to the final steps of, okay, I need to deploy only this, not only this jar in a Docker file or whatever, and this image, but I also need to add those services. I need to set up this Kate deployment. Okay, I will be using deployment in both meanings, sorry. Or maybe I need to set up multiple pods. I want to start a database. For this simple example, and again, it's a simple thing. If you have any question, just ask. We are going to use this application. This is built with Gradle. So here in the build step, to understand how scaffold works, it defines your whole pipeline to different steps. The most key important are just two, build and deploy. And basically, those are the ones that we have been using for 2 years. So no need to worry too much about the rest, because you have like an init, post-init, and several hooks. But don't worry, you just need to specify the build and the deploy. Our build is just running a boot build image. Basically, in our Spring Boot application, we use the Spring Boot plugin that takes care of building the images for us. It's using Pacquiao under the hood. We specify our sources. You will see why this is important later. And then for the deployment, we say, okay, when we deploy, we not only want to deploy our applications, but we also have this manifest. And if we go to the manifest, by the way, can you see it fine? I see people nodding, so I take that as a good sign. To keep things clean, we have our own namespace. We have the Kate deployment. Don't worry too much about the tag of the image we are deploying. Scaffold is smart enough to say, okay, I know you are referring to the image that you are building and deploy. So long the name matches, that's good enough. And then we're adding a service, just so we can access the pod, for instance, in case that we want to run multiple replicas. There are a couple of extra configurations I'm hiding to show you later. So seeing that, if we just go to our folder and we want to start it, we just run with the scaffold dev. Scaffold has several modes. Dev is like the development essential, and you will see why. It's now building the application. You see, this is just the Gradle build, nothing special. And of course, some people may say, hey, I can just do that with a bash script, right? But yeah, but it's also extra code that you need to maintain and things like that. So we really recommend using these tools. You can see this is just the step in which Pacquiao kicks in. Pacquiao, if you don't know it, will detect the type of application you are using. Here it's detecting that it's a Java application, and we'll use this image to compile and run, and then it's also a Spring Boot application, and with that, it takes care of building the Docker image. Also, at the end, Scaffold has another nice thing. It detects we are running on a kind cluster, because I already have a kind cluster that I started before the session. So it takes care of updating the registry that is inside kind. He did not mention that, but that's also a nice addition when you're running and building locally. You don't have to start pushing images to a registry, and then also you need to set up maybe credentials for the registry, and that's kind of annoying because someone in the team updates the credentials for the registry, and of course, everyone is sharing credentials. And this is why the dev was nice. When you run in dev mode, it just pipes all the logs from your application into the terminal, and you can see everything live. So if we just go to our endpoint, we can see our application. The most amazing code in the history of humankind, I know. And some people may say, hey, wait, but you are not supposed to do that. How can you access directly your application that is running within a cluster? That's another nice addition that we have with the Scaffold. We can do this, if I can find it. Yes, we can also automatically set up a port forwarding. So you don't need to worry about port forwarding. If you have had to deal with that, usually you just have to have one or several terminals opened, keeping port forwarding alive, and it disconnects, and you have to run it again. So this makes things easier. And to make things even nicer, and also talking about this way of developing in a comfortable and nice way, remember we set up this. So let's say you want to do a change here because the managers are not happy and say, we need more visits. Stakeholders want to increase the value of the company. So let's just add some nice business data into the system. A scaffold detected that we are changing the sources, and it's building again for us, and it will deploy automatically. So that's also kind of a, other frameworks or tools sometimes have automatic live reloading. So with a scaffold, we get that for free. Of course, since it's running in a local cluster and needs to build, deploy the image, it takes a little longer. And of course, this does not replace that you should be building your test. But it's a nice addition, especially when you are trying to iterate or you are testing something, which happens a lot in Kates. Okay, so we should be able to see now that we are jumping in steps of two. Okay, scaffold. So the next thing is Cloud Code. Cloud Code, it's a set of tools for development in cluster. If you check, we just have a plugin for IntelliJ. There is another for VS Code, if whoever likes using VS Code. And Cloud Code integrates really with Scaffold. Both tools come from Google. They work hand by hand, and they allow you to make things even a lot easier. For instance, and that's basically why we use the Scaffold, because this is simple, but sometimes you have several services connecting between each other, and you have these situations of synchronicity, and you don't know what's going on at the end of the day. When you are running something for some time, you want to actually debug, because we are Java developers, we are used to using the IDE, we are used to just debugging things. So once you have the plugin installed, you can just create a configuration. I already have one created. It's as simple as new configuration. It will detect that you already have a scaffold configuration of your project if the file is at the root. It will even parse the file and detect, okay, here is just deployment. So if you have multiple deployments, you can see that here. And if you have some issue in the configuration, it will tell you here also. And we can just run the bug as you would do in any Java application. It will start again. Some colleagues in the team even just run play, and they just have it running in the background all the day, so they don't bother about the CLI. I'm more of a CLI person, but it's a matter of taste. So if we go back to our endpoint, and let's say, this is it. We are just debugging. Sorry.
Yeah, I just had a question. So it looks like you had to restart everything there. Is there a way to just hook in and do remote debugging on the existing running process, or does it have to be restarted? Or that's what just happened?
Yeah. That's an excellent question.
Have you tried this with Quarkus, the scaffold part? I know you mentioned the auto build and all of that.
No, I haven't, but there's no reason why it should not work. At the end of the day, it's just running the whole process. If your Quarkus application, you are using a Gradle or Maven build, you can just set up the command here, and it will just build and deploy and nothing special. We will see later how this is done under the hood. So we will see that it's basically just injecting the environment variables for a remote debug as you would do normally. The nice thing about the scaffolds, and I think I cannot emphasize this high enough, is that it just automates all these chores for you that you really need.
Yeah, and sorry to interrupt, but to me, like the scaffold things that you have one command to run your project locally. And for all the team, so this is the big change. So this is a demo, but you have like some metric system, you have some Vault, you have some other components, you have one command for your whole team to run everything locally. And to me, that's the killer feature for our scaffold.
Yeah. Continuing with this, let's say because we are debugging and we want to time travel, and let's say, okay, we are in 2044, just finish the execution, and hey, that's what we got. So it's actually, and this is, I think it's clear by now, this is a little bit inception, is you're debugging into a process that is running in a container that we just built, that is running in a local cluster. In the cluster, it's running inside Docker, and it works because software layers. The next thing I want to show you is because, okay, so far, with Alberto, we got our cluster. Now we have some nice iteration loop. But sometimes you just want to keep an eye on things. And you don't want to mess with the commands like, okay, get pods. Oh, okay, I have a deployment. I want to see the logs of that pod, and I don't remember the name of the pod, et cetera, et cetera. So we have things like K9s. K9s is quite popular already, so I assume most people know it. But it's still very useful. It provides like this cool terminal UI, which is also, how to say it, nice and kind of hackery method. So it's also cool to show with your friends. And this just allows, as I was saying, just explore the cluster. It's the same that you can do with the CLI, but just here. And let's say you want to monitor a process, so you can just put it here in the corner and choose a screen, and this will update the logs while they run. And it's really nice. The issue, with great powers comes great responsibilities. So it's, well, just beware with the shortcuts. You can delete the stuff. It happens sometimes like, okay, I don't know what's going on. Oh, okay, my thumb is in the incorrect place. And this is for, let's say, us people here that we more or less enjoy terminal. But sometimes, let's say terminal is not good enough because you have those shortcuts and things, and you want just make things a little bit easier, or you have to do a presentation or show something to someone. And for that, we can use Octan. This is relatively new, and it's pretty cool. Anyone have seen Octan before? Okay, I'm going to type now. That's just for free, just running the command. You get a web console similar to K9s, but this is just web, so it's nicer. Don't use that as a dashboard, by the way, because you see that and you may think, oh, this is like the Kate's dashboard, or the dashboard, for instance, if you have seen OpenShift or other tools. Don't use that. That's mostly for development.
May I ask why?
Because it's maybe not GA yet.
There's actually not a lot of, it's not super stable. So this is more like an application live view of your cluster. So it's not meant to be a long running process, because at the end of the day, it runs locally, and I don't think it's optimized to be garbage collection. Everything is not optimized for a long running process. However, it uses your local permissions. So you are gonna see only what you have access to. So you have it set up somewhere where you have permissions only to see that type of cluster, then it should be fine. So you don't need to install anything. This is just a binary that you install locally. So it's kind of nice for that. But again, we have never had the.
No.
I don't know why would I do it, but I guess some people might.
Yeah,
but I don't think it's the intention, no?
No, that's not the intention. So far, it's just for development and internal. As he was mentioning, it's not very stable. If you let it running, you will find that maybe after 20 minutes, 1 hour, the process crashes, and you just run it again. I guess you could try to force it with a deployment engage, but it's definitely not something you want to do production. But for us, or as I was saying, like a small demo to the manager, like, hey, this is what we are doing, and you will see why. It's nice. For instance, here, and there are two main reasons why I use this. Is the first of all, of course, I can just go here and see my deployment and my information. The first one is the resource viewer. This shows a graphical representation of what you have been doing. When you have multiple services and a database and things connecting, this is really nice. Like, okay, this is, I can see an overview of what I'm doing. Even, and we'll see when we talk about tools, if you are deploying some third-party component using some tool, and that deploys several things, that also allows to see, okay, I know now what is running in the system. And here we can see basically the deployment, the replica set under the hood, our pods, the service, and even the service account, which we just don't set up. This is the default for Gates. The other nice thing I really like to use that for is events, because in Gates, the weird thing is that things work fine. I mean, you know, eventual consistency. It will eventually work fine. And then you always have to check the events. The events in the CLI are really not nice. Just to order or filter values, you have to start passing common arguments with JSON conversions and stuff. And here we have the nice view. So you can just explore the events, filter. This is not going to provide much because I think everything is, it's only my application running. But if you have multiple, you can just filter. It's really nice. It seems silly, but those are the small things that really help you be productive on the day-to-day. And in that line, the last productive section is, I mentioned before, kube context and Kubernetes. these are just two simple CLI tools. Kube context allow to manage multiple Kates cluster contexts. So if you have like your local kind environment, here for instance I have two kind clusters, and then you have your production environment, and maybe at the same time you're trying to troubleshoot what's going in the CI, so you are connecting directly to the CI cluster while it's running to see what's going on. You can just use kube context to change from one to the other. So if I'm here, I do get pods, okay, I can see my deployment. So this is the cluster I have been showing you, and I can just change to the other kube CDX kind cluster, and now I'm in another cluster, and you will see Devnexus is not running. And again, this seems silly, and you can do that with normal kubectl, but it has more complexities. And kubeNS, it's very similar. This is just for namespaces. So if I go back to the previous cluster, I love these tools because I'm especially lazy, and I don't like to have to specify the namespace all the time. So if I do kubeNS, I can just see these are all my namespaces. Okay, I want to work now in the Devnexus namespace, and you see it's auto-completed everything. Kube get pods. Okay, and that's it. I know it's simple, but that's like something you run 100 times a day. And with that, we finished the amazing experience of how we develop our applications. And now Alberto will continue with security.
Do you have any questions before?
Yeah.
So basically, okay, so that's day-to-day, local, and
even CI.
fix the defects, et cetera. Then you switch your context to your real cluster. So
Depending on the scenario, yeah, you could do that.
So how do you guys deploy? Let's say your developer's done. So pretty much everyone does that. They set their context to the whatever cluster you have out there, GCP, et cetera, and then off it goes. And it should work the same.
Yes. As Alberto saying, take care that it's using your local credentials, whatever you have in your kube config, but yeah, it should work the same. It's just, you can actually, I repeat that, you can actually do that with the normal kubectl config, kubectl config -- a lot of arguments, but this makes things just so easy that it's really worth it, and you can install it with Homebrew, install kube context. Both commands come in the same package. Also, there is packages at least for Arch in Linux, so it's really simple to install, and it's really a shame not to show that tool. Okay, so now, yeah.
We use Helm for deployment from CI/CD. Would that be scaffold instead of Helm, or can those exist together?
They can exist together, but I would say that in fact they solve different problems. You would not use a scaffold in a production environment. This is maybe for CI you can use that. Okay, imagine the CI pipeline. I start my process like a Github action. I start first step, provision a runner. Second step, I create a kind cluster inside the runner. Next step, I build my process and deploy because you want to build your current branch. So you just use a scaffold for that. And a scaffold, other things that I have not shown, it integrates with other tools. One of them also is Helm. So if you are managing your own deployment, it's done in Helm, you can just point to your Helm charts, and it will just deploy everything using your branch code that has been just built. But that's for the CI. In production, you would just ship it with Helm and the proper image that you have built for that release.
And for local development too, like on our project, we have some things we install with Customize, some things we install with Helm, and something that is just a manifest. So we have 3 things that we do scaffold. When we do scaffold dev, you will go and you're going to go through the Helm charts that we want to install, so everything can work with scaffold. But the 3 things, and there are more, but the 3 that we have been using or we used Customize before. Then Helm today and some manifest, raw manifest today as well.
Yeah, very quickly, Scaffold has a thing called profiles. I have it here as a bonus if we have time, but I don't think we will have. So you can just define profiles kind of in Maven, so you can do extra things. So you could have like the default installation runs with a manifest, but then you have a profile that runs also the task of Maven to build or Gradle to build your charts, which is something we do, and then deploy it with your charts and say, okay, I want to deploy it now in Helm. So Scaffold is really, really flexible.
Yeah, and these metrics examples will literally do the same thing. Like, I don't want to install Prometheus every time I install everything locally, but sometimes I want to check things out. So we have a profile that calls metric of observability, and then we install Prometheus there with that profile. So it's that flexible. But again, for local development, I wouldn't deploy it to any environment with Scaffold. Cool. And now, I don't know about you, but security has been in our minds for a while. These past few months have been very crazy when it comes to CVEs in the Java world. And we want to show how are we handling this. Because at first, when we were started working with images, it was something new to me. So I was used to just get a jar file and deploy whatever into a pass. And I've been working with platforms as I said for a long while. But now I had to care about the GRE, I had to care about the operating system application is running into. So it was something new that I didn't really know how to handle at first. And we have been learning on the way, right? So now problems can come from different places, right? The operating system can have a vulnerability, like Ubuntu had one like last Wednesday, I think. The GRE, again, depending on what you're using, you see patches every other month. It's a little bit more stable, but you can have a vulnerability over there. And dependencies, right? This is the day-to-day, like every other day this week, you have a new one in a dependency in your project, right? So problems can come from these places. Then there are two factors that can cause us to be vulnerable. The first one is that we add a dependency that's vulnerable. For some reason, we just downgrade, or for some reason, we add something that is not the latest version available, and that can cause our project now to be attacked. And the most common one is that a new vulnerability gets discovered, right? So there is a CVE databases on the world, and they get published, and that say, okay, this is now public information. Please be aware that you need to patch this. So we're going to be showing how do we test these things, right? Sorry, I'm going to take some time for people. Yep. So this is what we do. So we run a scanner tool on 3 occasions. The first one on every commit. It could have been filtered to every time we change the dependencies, but because it's a very cheap process to run, on every commit we run a CVE scanner. We're going to show the tools that we use for this, but just for us to understand the background on why are we doing all that. So every commit we run a CVE scanner automatically. Boom, that for sure. Then every time there is an update to the CVE database, we also run the same check, because we want to know if the latest CVE that was discovered is going to affect us or not. And this happens several times a day. I don't know if you are scanning to or not, but if you are not, you will see how this process is, is there, is working a lot. And last but not least, we also want to scan into our release code. This is something that we missed once, because we ship installers. We don't do continuous delivery because we don't have an actual environment. We ship products. And it's something that it can be easily forgotten. Like if you're not doing continuous delivery, there is a window of time where you have your main branch that's up to date because you updated to the latest dependency, but what was deployed in production is actually vulnerable. And maybe you're waiting a week or two to deploy for whatever reason, and that window of time can cause you to be vulnerable, right? So you also want to scan every time there's an update to the CV database to whatever your customers are running or whatever you are running in production for every single version that people are using. And this is a use case that we missed before. So these are the scenarios, and now let's look at the tools that we are using to solve this problem. So the first one is Pacquiao Buildbacks, as Abel mentioned. This comes by default with Spring Boot, so you do boot with image, you are doing Pacquiao underneath. But if you are not, for whatever reason, you can do Pack Build. It's a CLI that comes for free. And the good thing about this is that automatically it's going to patch the GRE and the operating system, meaning that you just need to rebuild the project for you to get the latest patch available. Like last Wednesday, there was a vulnerability in Ubuntu, and our CI shouted at us very loudly because that happened. And because we saw it was in Ubuntu, we said, okay, redeploy, and automatically we picked up the new version of Ubuntu, and everything was fixed for us. So just because we're using Pacquiao, you had 2 layers less to worry about when it comes to CVEs and attack vectors. So literally a rerun because we were using this tool. So with these 2 out of the way, I want to show more or less how the dependencies work. Like what do scanners take as an input? There's a concept called bill of materials, or software bill of material, BOM or SBOM, and you can just get the one for your application or your image with PackCLI. But again, you are doing some open source licensing, or you're using any CV tool, you maybe know this, but this is basically a list of all the dependencies that you have in your project. So you run this command, and this is obviously a simplified version of all the dependencies that we do have. But this is the input typically to all these CV scanner tools. Okay, but also the one we are using today is called Trivi. It just gets updated very quickly. It's working very well for us. But again, there are a million solutions. And usually you talk to the SNCC guys, they're going to tell you use ours. But hey, there are many. It doesn't really matter. Just use any CV scanner tool. And again, this is like antiviruses. The best one are the one that gets updated the most, not the most popular. So be aware of that. And this is literally the command that we run on CI. We scan actually the image because it's easy. We say, okay, we only care about high and critical. Exit code 1, so CI shouts very, very loudly at us. And just the image name. And if you take a look, it goes and say, okay, I'm going to detect what operating system are you using, Ubuntu. Okay, nothing there this week. What are you using Java, I guess, or some language-specific filter, so the JRE didn't have anything. But you look at this, like this Jackson and Spring Bean, this is just for last week, literally. Like, this is the project that he built last week. And I scanned it, and it was already vulnerable in a week time. And these are actually critical CVEs that literally can cause a lot of harm to your application. So automating this process, it was something that we must do, because if we didn't do this, there's no way we can get away with this, right? So how are we actually maintaining this? Like, because this seems like a lot of work having to update. So we use a tool called Dependabot that may be familiar. That what it does is it scans all your dependencies, and every time there's a new version in Maven Central, it's going to create a pull request for you to your repo. And we automated that. So it goes and runs all our integration, all our test suite completely. And then we are good to go, right? So we have a PR that was created for us while we were asleep. We woke up in the morning and said, okay, this was completely, it ran all the tests, it is green. And as we speak, I think we have a colleague working on every time the CI is green, just auto-merge it, because why are we have been clicking the merge button manually, and we don't have to, right? So there's a command that you can tell to the bot, like auto-merge, and it will automatically merge everything for you. So you wake up and you see that it bumped automatically a lot of versions. Especially minors are fine sometimes. There's a breaking change, but I take it as a learning opportunity, right? So you have a minor or major version. It's okay, this morning, what is new? This is here, let's just check, okay, what broke, why, is there any nicer way to do this now? And you learn on the way, right? But typically, honestly, our experience has been very fine. Because when there's going to be a time when a CV is going to write to your project, and it's not the same to update one minor version, that's to update one patch version, that's to update 7 minor versions. I don't know about you, but I have suffered a lot in the past when I was in a very old version of a project. A CV came and now I had no way to update that quickly. And then you say, okay, this is vulnerable, our customer is vulnerable in production, we have to get this shipped now. And if you're not in the latest patch available, you are kind of doomed to fail, right? This is a good practice, even regardless of CVEs. Just try to be on the latest version available. And Dependable is easy for that. Also, there are GitHub Actions for everything now. And the Trivi has one that you can just create. I was playing with that the other day. And Dependable is also integrated with the GitHub, but I think you can install this bot wherever you are. It doesn't have to be on Git. We highly recommend you using this, right? So this is the kind of the summary for this section. So use build packs, and then you get for free OS and JRE problems fixed. Update very often for Dependabot, not only for the CVs that are out today, but for the ones that are going to come and to be on the latest patch available. And please just use a CV scanner. You will be surprised how many dependencies are vulnerable every single day. Okay. Any questions?
Cool. Okay. So doing like a quick recap of what we have been seeing. We started like, okay, we have a cluster, we are developing stuff. Now we have everything secure and we need to ship it. And okay, there are lots of moving pieces, and something that it's easy can just screw up. So I'll try to make it quick. We want to, sorry?
Tenemos 4 minutos.
4 minutos, okay. Okay, try to make it quick. When we were at the point, okay, we need to ship it somewhere and somehow, because people need to use that, we went through this kind of journey of, okay, what are the issues that we have right now? And what do we need to cover in the future? And what do we need to really at the long term? That is this concept, if you have read about day 1 and day 2 operations, like, okay, what I need to actually get to production. And once I'm in production, which is the day 2, what I need to keep that running and to keep updating and releasing my things. The first thing that comes to mind, obviously, it's customized, and that's we put it here, because that's the first thing everyone is going to find, and it's going to say, okay, the only thing I need is just some templating. because I have my application. If you remember my deployment before in the example, like Devnexus appears every 3 lines. I have my namespace Devnexus, my app is Devnexus app, and then I have my Devnexus deployment and my Devnexus service. So I just need to template that and add a couple of properties. The truth is that, okay, that's only for the manifest, but you still need to deploy and package and distribute and then manage the versions, etc., etc. And that's where usually you will say, okay, I need something else. And that's where the next step is Helm, as you mentioned before. Helm is kind of, I think, we can call it a standard de facto right now. You find a lot of products distributed as a Helm chart. A chart is just a package with the different manifests and options that you have to install something. For instance, imagine we work with Vault to manage secrets. So you have a Vault chart. So I can just run from the Helm command, Vault install, Helm install Vault, more or less. And you can install Vault in your cluster, and that's going to run. What is the problem with Helm? And that's are the 2 missing parts here is building. Helm doesn't manage the building of your application. Helm just ships the images, which makes sense. But when you try to manage the whole life cycle of your application, you need to manage that. Okay, how do I build from my source? And Helm doesn't support that. That doesn't mean don't use Helm. Of course, the final conclusion of this slide, if you want to take something, is choose whatever you need and whichever works for you. And Helm is very nice in the sense that everything is monolithic. It's a single CLI. So the introduction and the first steps are nice and easy, and the learning curve is not very steep. The only other problem with Helm also is packaging and distribution. Helm has this concept of charts, and that's why it's kind of a thinking, because it's opinionated. Some people say, no, that's good enough. I personally think it's not good enough. You have, in order to distribute things, Helm has a total different method. You have to deploy your charts under a URL, and then you can expose that, creating a YAML descriptor and publish that through an HTTP endpoint. And it's kind of, okay, I'm doing manifest, I'm doing gates, I'm doing CLIs, and all of a sudden I have to set up an HTTP server. And this to me, that was weird. But if it works for you, that's perfectly fine. And the final solution is Carvel. Carvel is relatively new and has a different approach. Remember when I said Helm is monolithic? Carvel, they decide like, okay, in reality, we just need to manage these kind of activities, templating the files, building, packaging. And they define different tools for each one of those. And then all the tools work really nice together. So you can just build your manifest with YTT and then pipe that to COBOL. And COBOL will use that also to build your application. COBOL, for instance, K-build. COBOL is how we call it informally in the team. Betrayed me. K-build, for instance, also integrates with Paquito. So you can define a K-build descriptor pointing to your sources and saying, okay, this is a Paquito build, and it will take care of building everything, and then pushing that to a registry. And then Carvel has a different concept from the Helm charts. It uses something they call package repository, again, with the idea that you can have this list of repositories and do that just pack install Vault, and it will be installed. And for that, to define this package and publish this package, you use image pkg. And to do the final installation in your environment, you use the cap CLI and then the cap controller. The cap controller is another opinionated piece because it's something you need to run in your cluster. This is handling all the installation, while Helm doesn't need additional deployments because it manages things using configuration using annotations and other elements in your deployments. But Carvel chose that option, and that's how it is. Just one thing I don't want to forget, which is a nice thing in Carvel, is that whenever you deploy, it shows you the diff of your deployment. So when you're deploying a new version, it will tell you like, hey, I detect that the previous version had this service with this name, now it has another name, or this before ran with 500 megabytes of RAM, and now it's asking for 1 gigabyte. Do you really want to? In that regard, Carvel always shows you what it's going to apply, and then you can decide, okay, yes, I want to deploy this or not. Helm is more like, hey, deploy it. And they say you can then grab a coffee, and yeah, but the problem is that maybe when you are back with your coffee, something is broken. How are we on time?
Man, time. No clocks.
So, I don't know. Should we? Okay.
No, we should finish.
Do you still are fine for a couple of extra minutes? Yeah? Okay. So final tips. We added this slide very quickly because it's like, okay, there is like things that we had to learn. One, keep in mind, everything is asynchronous in declarative. When you are starting to work with Kates, you have this idea, okay, I deploy this application, I deploy then the service, I deploy this other component, and maybe Kates, even when you apply the service after the deployment, because everything is asynchronous, it will set up the service before the pod, and then you can check the events, and you will see there is an error, like the pod is not running, and then you just need to wait a couple of seconds until the pod is running again. So keep that in mind when you're starting in Kates, and it's when you come from imperative languages, it's a thing to keep in mind. The other thing, use alias and your CLI. This is like the most important thing. Change kubectl to K. That's it. You saw me before, it's K get pods, K whatever. In fact, most people in the team have extra aliases because you are going to use that a lot. And the reason why you saw me stumbling with kubens and kubeconfig is because I use KNS and KCTX. So for me, typing the whole word, it's also kind of weird. Take your time at each step. As I was saying with the deployment, if you want to start playing with customize, play with customize. Once you understand that templating, you can change to another templating solution and maybe start thinking about other things. Don't try to rush to, okay, I want to do Carvel with the whole thing and manage versions. And if you have an operator, I want to version my API. Just take your time. It's not easy. Remember the iceberg thing. Don't let the details drag you, let the abstractions do the job for you. For some of us, or at least in a personal experience, when I began, I was trying to understand everything, coming from a ES vision of, okay, my deployment is, this is running a Java process, and then there is some IP tables configuration. Like, don't worry, the service will take care of everything, and the deployment will take care of scaling. Don't think about these kind of things. And finally, play with local clusters, and we show you how to build ones. Back in the day, it was hard to get like a Kates cluster to play around and learn on your own. Do that. Just keep in mind this. Obviously, there are some things like metrics and networkers that don't work on local clusters. You can work around that. But for 90% of things, if you want to learn and play, just play with that. And finally, the Dilbert, maybe think about that maybe Kates is not a solution for everything. So sometimes that's also important to keep in mind. Then final minute.
Yeah, some resources that I found useful while I was learning. Yep. The first one is a book called Kates Up and Running. It was, just basic information about what everything is, some basic definitions. It's kind of old, but I still think it's a very important one. Then you have Programming Kubernetes, and that if you are gonna build services or whatever that's gonna talk to the Kubernetes API, this to me is the best book that you can find today. So if you are gonna build services, then this is a really nice thing to do. Then the Sysdig team, every time there's a new major version or minor version of Kates, they explain exactly what's new. So your learning is a very nice thing to just go, okay, every other month you go and see what's new, and that was very useful for me. And the same goes in the Kates blog, the official one. So you just go and read what's new, and that was very important. It's something that I use for later. There's a presentation that goes deeper into all this development workflow that we have been talking, that Abel was showing us today. There's a really nice talk. And then some Kates resources that have been compiling over the years, like how to do like Prometheus, like how all the commands are just copy paste and everything just runs. So it's something I have been compiling for a while. And that's it. Thank you very much. Any questions? We're going to be around anyway, so please feel free to ask.
Question. Have you guys looked at Argo CD? Like, I noticed you were comparing customize, Helm, and that tool. I've never heard of this one. So Argo will take customize, will take Helm charge through your CD.
Yeah, the thing is, we ship installers that people install, or just the image itself, so we don't have like an environment to CD to. So that's why Argo CD didn't really make a lot of sense for us. Like if we do that in our continuous integration pipeline, it will be like way too much, because we want to re-experience what people are using. So we want to do Helm install in our thing, because what people are, or Carvel apply, well, it's going to be the same. We want to use the same thing.